afternoon and welcome to Embedded World. We are here in Nuremberg doing podcasts in the booth. My guest for this episode is Bart Stevens. He's a senior director with Rambus. How you doing, Bart?
Hey, Rich, thank you for having me here.
Oh, my pleasure.
I'm doing well. The show just started, so
it's going to be a good one.
We're still all fresh and happy.
Very good. So, just so the audience is familiar with Rambus, just very quickly, what is it that you guys do?
So Rambus these days is a silicon IP provider. Mm-hmm. Our tagline is making data faster and safer, and that leads basically concludes into two product lines. Mm-hmm. We do high-speed interface IP, digital controllers for, say, PCI Express, memory controllers, MIPI controllers on the interface side, and then we have this other product line where we do securing devices by adding either hardware accelerators, root of trust, dabbling in the post-quantum era, making sure that chips are future-proof with respect to security.
Very good. And you just announced a new product here at the show, right?
Yeah, so we are announcing and just actually have announced our next generation HBM4E, the extended version of the JEDEC HBM4 memory standard.
And the significance of that?
So the significance is that we all know about AI. We all know about these big data centers that are screaming for having needing more memory, faster memory, quicker access to memory, and this HBM standard that has been coming up in the last 10 years is now at its fourth generation. HBM stands for high bandwidth memory.
Right.
It's stackable, so instead of having these DIMM strips, you can actually stack, say, 16 devices on top of each other. 16, which gives you enormous capacity already, and then with the tightly coupled interfaces, it gives you high bandwidth. But you know, AI needs more, needs it faster, and so the underlying standardization body is JEDEC, and they make sure that everything is interoperable. They set the standards, and HBM4 is the latest one.
How new is the standard?
That's like a 2024 standard, which means that silicon came out 2025, and now the industry is looking towards the next version, the extended version. And to give you an example, HBM4 gives you 8 gigabits per second per pin.
As opposed to what was the previous generation?
And the previous was actually 9, which is higher, with half the pin size. So HBM3, 9.6 per pin, 1024 pins, you can do the math. HBM4 gives you 8 gigabits per pin at 2K pins. And now this HBM4E doubles that to 16 gigabit per pins. So that means that you have to have a very efficient controller. With this dense memory, it is also important that you basically can ensure data integrity, which at these intensities is quite important, but reliability tends to go down, cell sizes are down, the charges per cell goes down.
And are the memory manufacturers ready for this?
They are, but they also expect that the controller does more than, say, the old-fashioned refresh of, let's say, a row, like timed refresh. So these devices need to handle smart refresh, which is like a controlled refresh. Telemetry is connecting to the PHY in between the memory and the controller, is making sure that you can actually trust the operations. If you see, let's say, single bit errors pop up, you can wait a long time until data starts to fail, or you can start to take action. And this is where you see more intelligence enter into the controller design, which Rambus then supplies.
Very good. And the product will be available when?
So the product is already available in, let's say, beta releases.
Okay.
What our customers today do, there is a C model, which one could call as like 85% accurate, with respect to timing, 100% accurate with respect to functionality. Rambus is very closely embedded, if you will, with the actual memory device manufacturers, the silicon, like the SK Hynixes and the Microns and the Samsung. So we got all these early accesses. So the new designs, they are starting today, and they'll see, say, tape outs towards the end of the year.
Awesome. Thank you very much, Bart. That was Bart Stevens. He's with Rambus, and I'm Rich Nass with Embedded Computing Design.